So creatine is very well studied in a context of sports performance, less so in neuroscience. There are a few studies out there that are quite promising. They do seem to suggest that there can be benefits to things like memory, cognition, and brain health, like there are potential neuroprotective effects of creatine. Why would that be? The underlying cellular mechanisms are likely to be the same in the brain as they are in muscle tissue. What's different is the obstacle. So for a muscle cell under load, the barrier is time. You're maxing out on the bench, cells in your chest muscles are working hard, they need energy. And they do so with a molecule called ATP. T, because it's got 3 triphosphates, it's got 3 of these phosphate groups. It ejaculates one of these off, and that creates energy. Now you've got ADP, diphosphate, and homie's down for the count. He's got post-hydrolysis clarity. You need to break for a while. It's a rate-limiting step. It takes time for homie to go back to the cytosol, gather his resources, use up some oxygen, and become ATP again. But you're maxing out on the bench now. Time is of the essence. Creatine comes to the rescue. You've been taking creatine, it's hanging out in the plasma membrane, full of phosphate, just ready to donate those phosphate groups. That's why creatine benefits sports performance, because that is a rate-limiting step that it is overcome. Now, for a neuron, faster energy consumption, take it or leave it. It already has its own refractory period anyway. It's rate limited by its own damn self. And actually, despite the fact that the brain is the most energy consumptive organ in the body relative to its size, days where you use your brain a lot, it doesn't actually consume that much more in the way of energy. When cells are using energy, they're also like farting out waste. In this case, what we're interested in is oxidative waste. So you remember when ADP homie slinks back to the cytosol to become ATP again, it uses oxygen to do so. Reactive oxygen species enter the chat. Oxygen gone rogue, missing an electron, bouncing about, damaging other molecules in its path. Creates damage. Remember I said the brain uses roughly the same amount of energy, whatever the weather. What if we replaced some of that energy with a pathway that doesn't require oxygen? If you're supplementing with creatine and homie is sitting on the plasma membrane sucking up delicious high energy phosphate groups from the cytosol, you can do that. That is a plausible mechanism through which you can create energy for neurons to do stuff. That seems to me the most plausible mechanism through which creatine could be neuroprotective.